What is up, mathletes? Welcome back to another episode of Math with Dr. Math. And this week, we're going to be talking about compound interest. Don't go anywhere. So let's look at your credit cards. So go ahead, pull out your wallets, those purses, pull out those credit cards, and I want you to comment down below which one of those credit cards has the highest interest rate. What kind of interest rates are we looking at in those credit cards? All right, let's get rid of them. All right, so let's look at this example because again, a lot of people, millions of people are dealing with problems just like this, but they don't bother to do the math. So let's look at a few things here. All right, so let's get geeky. So we have this function here, and what this is going to do is model the amount an individual owes a credit card company T years after some initial debt. And if you look at those credit card statements, you're going to see a lot of people will get some great rates when they sign up, and then they have a little asterisk. So if you're late, if you miss a payment, if something goes down, look at that asterisk. I want you to look at what percent you're going to be paying, and you might be a little frightened. All right. So here's some things that happen. So we'll do worst case scenario. You can't make payments, right? So here's a scary scenario. If a person currently owes $1,600, so you bought that nice bed, right? I don't even know if $1,600 gets you a nice bed these days, and you're making no payments, right? Something happens, right? Because as we see this year, things happen. How much time will pass before the person owes $10,000? Check that out. You went from $1,600 to $10,000, right? Is that possible? How long would it take? Let's take a look, right? We need to know the math. So notice, this is our starting point. So when you see A sub W, that's our starting amount, right? Our initial amount. So we owe 1,600, all right? And let's put everything in. And what we're trying to do is we're solving for T here. We want to know after how long, right, in years, will we reach, and A here is our final amount. Our future value is that ending amount there, which is $10,000 in this case. All right, first things first, you have to identify what type of equation do we have here. And if you notice, our exponent has a variable, right? So when our variable is in the exponent, this is an exponential equation. So our first goal, right, is to solve to get this by itself, to isolate the base with its exponent. So let's go ahead and take that 1,600 and we're going to divide both sides by 1,600, right? So let's divide both sides by 1,600. All right, let's take out our calculator and we get 10,000. And for the sake of this video and we're doing this calculator work, I am not going to round, I'm just going to leave it as a fraction. Actually, this decimal, it's not too bad, so I guess I will, because I don't have a repeating decimal here. So I get 6.25, all right? So 6.25 equals e to the 0.215t. All right, the big mistake we want to stay away from that a lot of people make is they'll try to take like the square root or cube root. They'll try to do something in terms of a radical. They try to use some type of radical to get rid of this. No. This is an exponential equation. So to undo an exponential equation, we need the inverse, and the inverse is a logarithm. So because our base is e, right, to get rid of that, we're going to take the natural log, the ln of both sides. So write that down, right? This is only the good stuff you're getting here at Dr. Math Studios, right? So write that down. We're going to take the natural log, and notice a lot of people will just put like ln, and if you write it just like that, that doesn't mean jack, right? So you're taking the natural log of what? We need some argument. So put something in there. So here is 6.25. We're taking the natural log of e, easy e, raised to the 0.215t. And these are the inverse functions. So these two, in a sense, are going to undo each other. They're going to cancel each other out. And what that leaves us with is your exponent there. All right, so these guys, they undo each other. So we're left with the natural log, the ln of 6.25, which is just some number, some ugly number, and that's going to equal 0.215t, because again, ln and e, they undo one another. So again, make sure that's clear in your notes. All right, and most importantly here, make sure you already smash that like button, subscribe, because we got a lot of good things coming your way. All right, so we're solving for t, so let's go ahead and divide both sides by 0.215. Divide by 0.215. So let's punch all this into the calculator. Make sure you close those parentheses when you're using your calculator here. So I'm taking the natural log of 6.25, close parentheses, divided by 0.215. All right, so we are getting approximately 8.524. And let us know, mathletes, if you want to see a calculator video of how to use logarithms and natural logs, comment down below, let us know, and we got that video coming your way, right? So if you're curious, just let us know. So it's going to take about 8.5 years, and look at what happened there. That amount of 1,600 grew to 10,000 after 8.5 years. So again, this is important stuff because a lot of people use money to put themselves into debt. But imagine if you took that same amount of money and you invested it, right? You could see that after 8.5 years of growth at around 21.5% growth. I know it's a lot of growth, but still that same amount of money could grow instead of you losing that money. So that's another topic for a different video. But again, these functions, they tell a story. They either tell a sad story like this, or they could tell a good story that helps your money grow. All right, mathletes. So hopefully this was helpful. Hopefully this made sense. Make sure to like, subscribe if you want more videos, and let us know. We'll see you guys in the next video. Peace.